Welcome to this new series, and in this series I'm going to discuss the Shift 2 physics problems of AAI ATC 2021 paper, and this is the first video, and in this video I'm going to discuss 5 physics problems. So if you like the video, press like and share and subscribe. Thank you. So the first problem says a point is moving with a velocity of 10 meter per second, and at a subsequent instant it is moving at the same rate but in a direction inclined at 30 degrees to the former direction. Find the change of velocity. So if v1 is like this, then v2 is this, which has an angle of 30 degree with respect to v1. So the change of velocity means v2 minus v1. So minus v1 is basically the same vector but just reversed the direction, so the angle between the two vectors becomes 150 degrees. So you can use the triangular rule of vector addition to get this number. So that is v1 square plus v2 square plus 2v1 v2 cos 150, which means since v1 square and v2 square are the same, so you have 2v1 square plus minus 2v1 square into cos 150 is minus cos 30. Cos 30 is root 3 by 2. So you plug in v1 square as hundreds because velocity has a magnitude 10, so v square will be 100. So if you do that, you will get this equation, get this number 5.176, option A. Now the question is, second problem says a cage in a mine shaft descend with 2 feet per second square units of acceleration. After it has been in motion for 10 seconds, a particle is dropped on it from the top of the shaft. What time elapses before the particle hits the cage? So let me describe the problem a little bit. Suppose this is the mine shaft, and this is the top of the mine shaft. Now you have a lift here. This is the mine shaft. Now you have a lift here which is moving down with 2 feet per second square acceleration, and at some time t you drop a particle from the top of the mine shaft. Now the question is, after what time the particle will hit the top of the lift? Okay, so at that time the displacement has to be the same. So this lift is moving much slower acceleration than the acceleration of the particle. So let's assume that after t time the displacement would be same. So using the kinematic formula, S is ut plus half at square, and taking u to be 0 because it starts from stationary state. So for the case of particle, that is half g t square should be equal to half into 2 into t plus 10 square, because the lift is moving 10 seconds before the particle is dropped. So the value of g is 32 in feet per second square. So this is 16t square is t plus 10 square. You simply take square root both sides, so you'll get 4t is t plus 10. That implies t is 10 by 3, which is 313. That means option B. Now the question is, you have given a potential and you need to find out the components of electric field in Cartesian coordinate system. So as we know, electric field is minus gradient of V in case of two dimensions. This is dV dx I cap dv dy j cap. So if you take the derivative of this with respect to x, you will get minus y square plus 12 x square whole thing into I cap, and if you take derivative with respect to y, you will get minus 2xy j cap. So the components are option C. The fourth question says an object of size 2 cm is placed 18 cm in front of a concave lens which has a focal length 27 cm. Find the height of the image produced by the lens. So as we know, the magnification is defined as the image distance divided by the object distance. So we need to first find the image distance. So for that we have to use the lens equation, which says 1 by f is 1 by v minus 1 by u, given u is minus 18 centimeter, f is minus 27 centimeter, minus because it is concave. So 1 by v is 1 by f plus 1 by u, and v 1 by v is minus 1 by 18 plus 1 by 27, and if you calculate the whole thing, then the image size is height of image is basically m times height of object. So it should be v by u times a0. Here v will also come out as negative because you can see the negative side in the front, and u is already negative, so the whole thing would be positive, and the answer, if you calculate, this is simple calculation, so it would be 1.2 centimeters. Now the question is, a thermocol cubical icebox of side 20 centimeter has a thickness 4 centimeter. If a 5 kg of ice is put in the box, estimate the amount of ice remaining after 5 hours, and all the outside temperature is 35 degrees centigrade. Coefficient of thermal conductivity is given, and heat fusion of water is also given. So you know the rate of change of heat is the thermal conductivity minus the temperature difference times the area divided by the thickness x. So we have to find this dq dt first, given the coefficients. This is 0.01 times 35 minus 0 times area. Now you need to be very careful about the area. There are 6 surfaces of a cube, and each surface has an area of 20 centimeter square. That means 20 minus 2 to the 2 whole square divided by x. X is the thickness, which is given as 4 centimeter, right? So you calculate this number, that is the rate of change of heat. That means this amount of heat per unit time is getting inside the thermocol from the outside. So in 5 hours the heat exchanged is delta q is dq dt times 5 times 3600, because this is in joule per second, right? So this much amount of heat is got into the system in 5 hours. Now you need to find out how much water is how much ice is melted because of this heat. So you need to divide this heat by the latent heat of fusion. That will give you the number of kgs that have been melted, right? So if you do this, this is this would be 5 times 3600 and divided by 335 into 10 to the power 3, and you will get something like 0.198 or something. So the remaining would be 5 minus 0.198, which is 4.8 kg. Okay, so option C is the correct answer. This is a lengthy problem. Thank you.